Hello, everybody. Hi, everyone, and welcome to our data visualization Zürich meetup. So for those who don't know me, my name is Luc Guillemot. I'm interaction engineer at Interactive Things here in Zurich, Switzerland. Thank you so much for joining our session today. I organized this meetup with Benjamin Wiederkehr, who is also with us tonight in the chat. Yeah, and we organized this meetup to provide a space to share and advance the knowledge of our local community here in Zurich, and now like with the broader world since we are doing it online. And today we have something that we haven't had in a while, and the first time also online. It's more a workshop instead of a presentation. So we're gonna try to code together a little bit using Observable and Vegalite. So as you see, I shared in the chat and also on Meetup a notebook in Observable that you can fork and that you can edit yourself to follow along. So I try to make it as beginner-friendly as possible, but I think it's a little bit more tech-heavy for a meetup than usual. So let me know if something is unclear. Don't hesitate to interrupt me in the chat or ask a question anytime. Also, if I'm going too slow or too fast, don't hesitate to tell me. If you want to ask a question, you can use the button below the video feed, ask a question. And you can also upvote a question that you would like to see answered. So the goal for today's workshop is to explore what we can do with Vega-Lite and understand some basics, like the basic blocks of Vega-Lite. And we are going to also explore a data set about gender balance in the Swiss National Council since 1971. And we're going to try to sketch some visualizations. I am not really like an expert in Vega-Lite. I've started using it maybe like a few months ago. And like what we usually do at Interactive Things is like very customized application and highly interactive applications that have some complexity and also some state management, where usually I use mostly like more lower level libraries like G3, where you can like do more customized things. But I've really liked using Vegalite recently to mostly at the beginning of a project, in the exploration, conception, and design phase of the project, to sketch visualization with real data, to draw charts as quickly as possible, and also sometimes to incorporate them in a design software like Sketch or Illustrator. To design with real data. So I really liked it, and so we thought with Benji that it could be like a good topic to tackle in our meetup. So let's get to it. So I'm sharing my screen here. You can see like the notebook that I prepared on Observable. Let me know if it's too small or too big. So first of all, what is Vega-Lite? I copy-paste some definition from the official introduction to Vega-Lite. So Vega-Lite is a declarative language for interactive data visualization. Vega-Lite offers a powerful and concise visualization grammar for quickly building a wide range of statistical graphics. First of all, a little note about using Vega-Lite in Observable. So this is a notebook, and every everything is a cell that you can edit, and every time you see a cell like this one with a light blue-gray background, you can edit it, and it's code. You can edit it, and then if you click on the blue arrow here, or if you press Shift Enter, it will execute the cell. So here, of course, we have an error because like it's not correct syntax. So I'm gonna go back to what we had. All right, now it's correct. And so the first thing that we need to do if we want to use Vega-Lite in an observable notebook is to import the Vega-Lite library. And here we are using the Vega-Lite JavaScript API. So what we're going to write is JavaScript because it provides a very convenient way to write Vega-Lite specifications, and it's programmatic way. So what this line here does is import the library. And now we have this object VL, which stands for Vega-Lite, that contains all of the Vega-Lite functions, and that we can now use all across the notebook. So let's talk a little bit about some like the building blocks of Vega-Lite, and like also what data visualization is. Like D3, ggplot, or Tableau, Vega-Lite implements grammar of graphics, and it's inspired by works like Semiology of Graphics by Jacques Bertin, or Grammar of Graphics by Leland Wilkinson. And what is special about using this kind of grammar is that we don't use common chart names like scatterplot or bar chart, which are actually shortcuts to sets of data dimensions and visual encodings. And what we do with Vega-Lite is exactly that, describing these sets of data dimensions and visual encodings. So the elements that compose a data visualization. The three main things that you need to know about using Vega-Lite, the three mandatory elements that we need are a dataset, a graphical mark, and a set of visual encoding channels. So let's have a look at the first element, which is the data. So as I mentioned before, we will explore a data set about the Swiss National Council elected members. And here in this line, I'm using a little bit of D3 to import a data set, which is a CSV file. You can see in the notebook, you can see, like if you click on these three dots, there are some files that are attached to this notebook. And here you can see a file that is ch.csv, so it's a regular CSV file. And we can import it and make it available in the notebook using this little piece of D3. And what it does is creating a JavaScript array of objects where we have all the data that we're going to use now. And this data set that I named CH, it has 3 dimensions: year, gender, and elected. And these dimensions are of 3 different types. The first dimension, year, is of type. So it's actually a time value. But in this case, we can also consider that it's of type ordinal, since they are just years and not dates. And the domain for this dimension is from 1971 to 2019, with data points every 4 years, which is like every time there is an election in Switzerland. The second dimension is gender, which is of type nominal, which means there are categories. And in this case, the values for this dimension are Mann and Frau, which are German words for man and woman. And the third dimension is elected, which is of type quantitative. So it's numbers and spanning from about 0 to 200. Just a note about the ordinal dimension. It's a nominal dimension, so categories, but that has a set order, like age groups, for instance. So now that we have a data set, which is the first element that we need, we can go to the next element, which is a graphical mark. So it's the geometrical shape of the data point. And it can be a circle, an area, a bar, and like also actually a lot of others that that are defined in the documentation of Vegalite. But like these are maybe the easiest one. And in this cell here, you can see that it's our first data visualization built with Vegalite. It's not very impressive yet, but it will become more interesting, I hope. So the first thing that we do here is using this VL object that we imported just before. And we always start a visualization in Vegalite with this VL. And starting from that, we can chain some methods with this dot here that we can see. So the first thing that we do here is defining the graphical mark. And here we use a circle. And then we tell Vegalite where to take the data. So here I use the method data, and I say that our data set is CH, which is the data set that we defined just before. And then the last thing that we do here is invoking the render function, which actually tells the browser to actually paint the visualization on the screen. If I remove it and I execute the cell, then we have only the specification of Vegalite, but it's not drawn in the browser. So let's add it back. And so we have our first data visualization, which is extremely basic because since we don't have any encoding channel yet, all data points are stacked up upon each other. So now let's add some encoding channels. So encoding channels can be, for instance, X, Y, color, latitude, also size or opacity or stroke width, or many others. So there are the visual variables of the data visualization. So the visual things in a visualization that we can use to encode a data dimension. And here in our data set, as we have 3 dimensions, we can use 3 encoding channels. So this is what we're gonna do now. In this cell here, so the 2 first lines are exactly like the previous cell. We use a circle as a geometric, like as a mark. Then we use the same data set, CH. And what we add here is the definition of the encoding channels. And the first thing that we do here with this line is to say that as the first encoding channel, we want to use Y, so the vertical axis. And we are going to use this channel to encode the field elected that is of type quantitative. And this is the result of adding this encoding. So if I remove it using this // which comments out, oh yeah, so I need to remove this also. But then we have the same as before, just the dot. And now if I add the first encoding, for Y, then we have the Selector Visualization, which is already something we can see the distribution of data points along the Y-axis. Yeah, so we can see that it spans from about the font a bit bigger. Yes. Is it better? Yes, so we can see. Thank you for telling me, Teresa. So we can see, yeah, that the data span from about 10 to 190. And what we can see also that we can like already see kind of two clusters of data points. So let's add another encoding channel, which will be the x-axis. So here you can comment out this line that I already prepared. And we want to encode the field year on the x-axis. So again, we call this VL for Vega-Lite, and then we tell Vega-Lite that we want to use the encoding channel X to encode the field year, which is of type ordinal. And now if I execute the cell, ta-da, we have kind of a timeline now. So with the years from 1971 to 2019. And we can see like already some kind of progression here and some kind of a decrease here. So I guess you know what those values are, since you know the third dimension that we have to left to encode. We can see here that we have 2 data points per year, like for 2011, for instance, we have like a data point here and a data point here. And we want to use another encoding channel to differentiate those 2 values. So that's what this third line here does. We want to use color to encode the dimension gender. So again, we call the L, then the color. We say we want to encode the field gender, which is of type nominal, and I execute the cell. And now we have 2 different colors. Like at the bottom in blue, we have Frau, so women. And on top, we have the orange circles, which are numbers for men. Yes, if we want, we can try something. If we change the Y, the type of the field that is encoded on the y-axis to ordinal instead of quantitative, and I execute. Now we have the same like values for the data points, but they are considered to be categories instead of numbers automatically by Vega-Lite. So it's not what we want. So I'm going to go back to quantitative. Quantitative. Here we go. Yes. And like another note about this, we can use a shortcut for field and type definition at the same time by using this field N, which stands for field nominal. So if I do this, then we have exactly the same thing. What is interesting to note here is that there is like very little code that we have written yet, but we already have an axis title, colors that are defined, legend that appears here. These are all handled by Vega-Lite, like without us specifying anything, because it has very useful defaults that helped us like create very quickly visualization without having to define absolutely everything. So this is why I think Vegalite is very powerful to quickly explore a data set and like sketch data visualization. Yeah. So about the encoding channels, the first person to really define a system about these channels is Jacques Bertin in 1967, and he defined at the time 6 visual variables: size, value, texture, color, orientation, and shape. And Vegalite actually adds several others like opacity, stroke width, text latitude and longitude, or tooltip, and others. Yeah, so don't hesitate to go to the Vega-Lite documentation to have a look at all the encoding channels. Yeah. So to summarize these 3 main elements: dataset, graphical marks, and encoding channels. So what I said just before, with so many useful defaults, we don't need really much most of the time, and it's very easy to modify these parameters to create different charts. For instance, we can try, instead of circle, we can try to have a line. So we change the mark here, I execute, and then we have a line chart. I can also use bars like this, and then we have stacked bar charts. I can also use an area chart, an area mark, to create an area chart. And here again, we see that Vega has useful defaults because it stacks the areas on top of each other, so that we can see that there have been 200 elected members in the Swiss National Council since the beginning. And like Vegalite assumes that we want to stack the areas, which is like right in this case. But if we don't want this, we can say that on the y-axis here, we can say stack equals false, and now the areas are not stacked anymore, and we have actually a mountain chart. But it's probably better to have them stacked. So let's keep this, or let's remove it completely. We can also try adding some other encoding channels. For instance, we can add a tooltip. So again, we call VL, and then as encoding channel tooltip, and then we say in this array the field that we want to see in the tooltip. So I execute the cell, and now when I hover on the chart, we have a tooltip with the year, the number of elected members, and the gender. So here, Frau and then man. We can also add a facet, which creates small multiples. So if I execute the cell, and then instead of 1 chart, we have 2 charts, which can be very convenient. You can also add some opacity if we want. So here I say VL.opacity. And here something interesting is that we don't map the opacity to a data dimension as we do here. For instance, we map the facet to the data dimension gender, but here we just define 1 value, so it's applied to all data points. So it's more styling here. So that's it for the very basics of Vegalite. If you have any questions so far, don't hesitate to ask in the chat. And we can go to the next section about styling and exporting. As I said, I often use Vegalite to quickly explore a data set, and then during the conception phase of a project, and then sometimes I use it then in another design software. So it's good also to add a little bit of styling and know how to export something that we create here. So here, this is like the same chart as what we had just before, and I prepared a few things that we can add to the visualization to make it a bit nicer. So first, there are things at the view level. So like things that apply to the whole visualization. For instance, we can add a title. Yeah, so I said no gender parity in the Swiss National Council. And if I execute this, we have like a title here. We can change the width, and then it's a bit larger. We can change the height, and then we have something a little bit less high. We can also add a title to the axis. So here, like we are in the encoding part of the visualization, the encoding channel X, which encodes years, and we want to add a title, year of election, instead of the default, which is the field name here. So I execute this, and then we have a title here. We can do the same for the Y encoding channel. So don't forget to remove the comma here, otherwise it will break. So I add a title here, member of parliament in the National Council. And something else that we can do on this axis is to add a number of ticks. So ticks in an axis are these lines here. So if I say that I only want 2 ticks using this like object with the property tick count, and I execute it, and then we have actually 3 ticks, 0, 100, and 200. Yeah, for those of you familiar with D3, you can see that Vegalite is actually based under the hood on D3, because these are the kind of of things that you also need to define in D3. So a lot of properties are similar. So you're not completely lost when you come from the world of D3. Now we can modify also the encoding channel color. And something we can do is to change the color that I use here, like this blue for Frau and orange for man, which are the defaults from Vega-Lite. But let's say that we want some orange for women and gray for men. So remove this comma here. And I prepared here some code to add a scale. So a scale is, so I wrote a little description, explanation here. Scales are functions that transform a domain of data values like Frau and man to a range of visual values like colors in our case. And this is what this line here does. We define a scale for this encoding channel where the domain, so the dimension values are Frau and man, and the range, so the visual variables that we want to associate, are orange and gray. And here, Frau is the first item, then orange applies to Frau, and man becomes gray as a second item. So now I execute this, and the colors are changed here and also in the legend. Maybe here, like we don't want a title at all because it's obvious what it's about. So I say that the title is null, and then we don't have a legend title here. And maybe I also don't want the legend on the right, but I want it on top of the chart. So this is how I do it. And maybe we also want to change the width of the line here to have something a little bit more fat. So we can use the encoding stroke width. And here again, we apply these to all data points with a value of 5. And now it's a little bit larger. And if we want, we can also, like, as an example of other encoding channels that we can use the stroke dash and also use it to encode the dimension gender. So I do it, and then we have a dashed line instead of a plain line. So yeah, it's probably not what we want, but as an example. And then last thing that is very useful is that the render method can take an argument, which is the renderer engine. And here I can say that I want SVG as an output. So I execute. So nothing changed in the visualization. But now when we click here on the three dots on the left of the cell, we can download the visualization as an SVG, which is like very useful if you want to use it further. So now I want to talk a little bit about data transformations. Like so far, we only had 3 dimensions, and we kind of mapped the data points directly on the chart. But sometimes it's not what we want. We want to reshape a little bit the data set before visualizing it, which allows us to encode dimensions of the data that are not present in the raw data set. So for instance, maybe here we want to filter out the values for men, and we only want to see numbers for women. So it's called filtering. And how it works is using a transform function. So here it's again exactly the same base like mark area, datasets, and encoding channels as before. But what we can add is a transform function here. So I'm going to uncomment this so that you can see better. So we change the method transform, and then here in this line, we tell Vega-Lite what data transformation we want to apply to the dataset. And here I'm using the filter function. And here we tell Vega-Lite what filtering function we want to apply to every data point. And here there is like a syntax that you kind of need to learn, is that you have to use datum, which means that we go through every data point, and datum here stands for one data point. So what it does here, it says for every data point, look at the gender, and if it's Frau, women, then you keep it. And it means that if it's not, you don't keep it. Now, so with this transform function, if I execute the cell, we have the numbers only for women. Another data transformation that is very useful is the aggregation. So here on the left, I created this like little illustration of what happens when you aggregate. So we have our 3 dimensions, and after an aggregation function, if we want, for instance, the average of the numbers of women and men across all years, and so what we want in the end is this this table on the right. We can use an aggregation function. So this is where it happens. So how it works, here we call again the transform method. And here with these lines, we tell Vega-Lite that we want to group the data set by gender. So like these lines, for instance, they become one group. So one group for women and one group of data points for men. And on these groups, we want to aggregate, so create one value, one number. And what is this number? We want it to be an average, and the average of the number of elected members. And this last couple of this last method, as it tells Vega-Lite that we want to use this name, gender aggregated, as the new field of the data set. And because this transformation function really creates a new data set, and now it will have these new fields that we can use then in the visualization. And that's what we are doing here in the encoding method. Again, so for the X encoding channel, we use gender. And what changes here is that for the Y encoding channel, so this one, we use the new field that we just created, which is gender aggregated. Yeah, and we also have a tooltip that is not really necessary here. And yeah, just the color, which functions exactly as before because the domain is the same. Here, now that we have gender aggregated, if I try to use elected instead, I think it doesn't work anymore because we removed this data field by aggregating it in this function here. So like in this example, like in this illustration, we have gender aggregated, and elected is like containing these numbers. So let's write back gender aggregated here. The last data transformation that I wanted to share with you is pivoting, because it's something that I personally struggle with very often when I have to do such a thing in pure JavaScript. And with Vegalite, it's made really way easier, so it's really great. And what it does is going from a long format, which means we have everything as all dimensions as columns, and we want instead something wider. So which means that we have one column here, gender, with numbers for women and men, but we want these dimension values, Frau and Mann, as dimensions, so fields in our data set. And it's very convenient, for instance, if we want to create a scatter plot, which means that we need two dimensions that are quantitative. And here we have only one elected, but after pivoting, we have these two quantitative fields that we can use to create a scatter plot. So how it works, so here I use mark point, same data set, and this transform function where we group the data by year, and then for yes, for every group by year. So for every year, we have a group with a man and a value for man and a value for a woman. And we want to pivot this dimension, gender, and to create a new dimension for every dimension value here. So dimension values, and now they are dimensions. And we want to use the number elected. So here, this number for Frau in 2019, we have it now in this column here. And after transforming our dataset like this, we have two new field names that we can use in our visualization. So here, what I did is using Frau for the X encoding channel and man for the Y encoding channel. So we can see that there is like kind of a tendency to towards more parity. I see that there's a question. Luke, you said you usually just sketch a project with Vega-Lite. What limitations or requirements are there that make you switch and into what tools or methods? Yeah. Most of the time, I indeed mostly sketch with Vega-Lite, and then when it comes to really creating a whole application, I find it personally easier to use lower level libraries like D3 and also React to create visualization, mostly because it's easier to share state in the whole application. And also, I think that there is a little limitation after a while in using Vega-Lite in how customizable it gets. If you want to create something that is really really unique, then I think it's actually easier with lower level libraries like D3. I have, so we're almost done, but I added another section about faceting and layering to create kind of more complex visualization. So I see time is passing quickly, so maybe I'm gonna go a little bit quicker on these visualizations, but just to show you also what we can do, because it's very rich still. So I created another data set, which is the same as before with your gender elected, but has also a new dimension party, so that we can look at numbers by party. So actually the four major parties in Switzerland: FDP, CVP, SP, and SVP. And here, what is different in this visualization is that we use faceting here to create small multiples. So if I remove this, the faceting, and I execute, then we will have something that doesn't make any sense, because the dimension party, which is here, is not encoded anywhere. So we have multiple data points per that are kind of stacked up on each other, and as we have areas, it doesn't really make any sense. Maybe if we use circle here, probably we can see all the data points. So we have 8 data points per year for every party and every gender, which is not what we want. So by faceting, we create 4 of them, and then we separate the kind of we encode the remaining dimension by using small multiples. And lastly, so maybe you noticed, but a few meetups ago, we had a presentation by Han Zimmerman, which is the design studio in Bern, and they presented one of their projects which is like this visualization of the proportion of women elected in the parliament on X, and the number of seats that every party won this election on the y-axis. And I tried to reproduce this visualization with Vega-Lite. And so that's kind of what I did here. Like, it's not as nice, but the data is the same. And so there is like a lot of things going on here. So maybe I'm just going to point at a few things that are interesting here, I think. One of the things that I do here is layering. So we're gonna start here at the bottom. I'm using this Vegalite method layer to put on top of each other points and lines. So you can see in the chart, there are the points and the lines, and they use the same data set, but two different marks. And to layer like things on top of each other, this is how you do with Vega-Lite using this layer. And then we have these layers that are faceted by party again. The data set that we use is called parties. And here there is a lot of things going on to transform the data set. First of all, we group here by year and by party. And then we pivot on gender using the value elected, the values of the field elected. So now in our data set, we have two new columns for Frau and man that we can use next in this line here, where we calculate a new field. So we add a new column to the data set, which is the total number of seats that a party won for a year. And here we use again this syntax datum.frau, and I add to this number the number of men who were elected at the same year. So here we have a new dimension, number of seats, that is still grouped by year and by party. So this is why these numbers that are on the y-axis are still numbers for each year and each party. And we also add a new dimension here, which is the proportion of women who were elected this year in this party. And same thing, I use here a calculation, datum.frau divided by the number of seats multiplied by 100. So we are calculating a percentage. And I name this new dimension proportion of women. And now I go on top here, and we have this value specification for the points, which uses like the mark circle, and in the encoding channels, I'm using the fields that we calculated here, proportion of women and number of seats. So in X, proportion of women, and on Y, the number of seats. And what I do also for both of these encoding channels is sorting the values by year, so that they are displayed like in as a timeline. And I also add a color by party, so like these canonical colors for parties. that I defined here in the scale. What I do here then, using the encoding channel size, is something a little bit like new, is that it's conditional. The size of the circle is different for 2019. It's a value of 100. To do this, I use this if here. So it means that encode the size, and if the year is 2019, use this value, and otherwise use this default value of 30. So this is why the circle for 2019 is bigger than the others. Yeah, and then we can also like change fill opacity, like add a tooltip. This is what appears when we hover on a dot. So we have the data values. Then something also new that I'm doing here is creating this lines const. And it takes everything that is defined in points, so what I just defined here. So it will use the same X and Y and color encoding channels. And I use a different mark, which is the line. And so this is the line that we see like here. And here I just encode specify the size of one pixel. Otherwise, it would use the size that we define for the circles, and it wouldn't work. Like if I remove this like this, then it creates these very big lines. So skip it. Yes, and then that's it actually. Like now we can stack on top of each other these two visualizations. Yeah, so I went a little bit quicker on this one, but it's also to show you like everything that you can do with Vegalite. And actually, there is a lot more that you can do. We only scratched the surface there. And you can go look at the official documentation of the Vegalite API, and you can do like maps like this, for instance. You can do actually highly interactive visualization like this chart, where you can brush on the top chart to filter the data that is displayed in the bottom chart. So if you want to see like the data for April, for instance, May, so it's very rich. And you can see also that this is the code that is used to create the visualization. So it's a little bit more than what you wrote, but also not that much more. So I really encourage you to look at these examples and to try to understand what's happening there. I added at the bottom of my notebook some sources where you can find examples and more documentation. I highly recommend the visualization curriculum written by Jeffrey here, who is one of the contributors to Vegalite. Also, I did some more theoretical books and articles about the grammar of graphics. And also, yeah, some inspiration from Hans Zimmermann and the particulars defined by Angelo Zer. And also an appendix to show how the data is prepared and the libraries that are used across the notebook. All right, that's all I have now. So it went a little bit longer than I thought, but if you have questions, please don't hesitate to reach out to me or to ask them now. And don't hesitate to share what you do with Vega-Lite also on meetup or on Twitter. Earlier you mentioned that you also sometimes take the Vega-Lite draft and then use it in some design tool like Sketch. You export, import an SVG, and then play around with the colors, etc. Or how do you work with the design tool? Yeah, exactly. I export it like here in the renderer function. You can add that you want as a renderer SVG. Then you execute, and then you can download it here. And so if you click here, it downloads a file that you can use very easily in the in a design software. Or also directly in an application with code. Thank you very much for your messages. Is there any use case where it could be useful to convert Vega-Lite code to pure Vega JSON and work with the Vega JSON directly afterwards? I have never done this actually. I think like look at the output from Vega-Lite to Vega, because like yeah, Vega-Lite is actually a layer on top of Vega. So Vega is kind of a little bit more complex and also more rich a library that is like more customizable and has some other features. And yes, I have actually in an application, I tried to use a pure Vega and not D3. And I had chosen to use Vega, not Vega-Lite, mostly because I wanted to really control the data flow. And also like it's a little bit at tooltips. It was like easier to use Vega that has a feature called signals, and it helps with like also the interaction. Thank you, Teresa. I hope I answer your question. How much can you influence the look of Vega charts? How much is left to do when beautifying charts in graphics editors? I think you can really do a lot with Vegalite. I think it mostly depends on like what you want to do with your charts. Like if you want to do a notebook exploring a data set and creating visualizations and like write an article about it, then Vegalite is like way enough, largely enough. You can really customize a lot. But if you want to include it in a more broader design and like a whole application design, then this is when it becomes easier, I think, to download and like rework in a broader design system, I would say. I hope I answer your question, Caspar. All right. Thank you very much for your question and your participation. I hope I was clear enough. Don't hesitate to give me like a feedback or ask further questions if you want to. Yeah, so thank you everyone for showing up and contributing. Don't hesitate to reach out if you also if you want to like our next meetups to be about like some potential topic that you would like to see covered. If you want to speak yourself also at the meetup, don't hesitate to reach out on meetup or Twitter or by email. Yes, and our next meetup will be in September. We will talk about creating empathy with data visualizations, and we will have a presentation by Gabrielle Merit, with a data visualization designer, and she will like share with us some of her work and her ideas. So see you next month, and thank you very much again.